The 11th tutorial covers different matching procedures to help you merge the pairfam datasets. Why should we merge the pairfam data? As the survey data is stored as separate cross-sectional datasets and organized by different actors, you will likely need to merge different actor datasets and/or several waves to answer your specific research question. To analyze change over time, you will need to merge the different waves, for example waves 1 to 13 of the anchor data. For multi-actor analyses, you will need to merge the datasets of different actors, for example the anchor with the partner data. Which data formats exist? There are various data formats: wide, long, and spell. In the wide format, each row represents one case with a unique identifier, and time is structured in columns. This means that a separate variable contains information for each time point. For example, the variables satisfaction with life in wave 1 and satisfaction with life in wave 2, and so on. In the long format, each case covers several rows, with a unique combination of identifier and time. Time is structured in rows, meaning that one variable contains information for multiple time points. In this format, one variable, satisfaction with life, contains the response to life satisfaction in wave 1 in the first row, life satisfaction in wave 2 in the second row, and so on. Spell format also contains several rows per case. However, the rows don't represent different waves, but different statuses of an individual. The biodatasets are stored in spell format. The biopart dataset, for example, contains one row per anchor relationship. In the following, the focus will be on merging the data in wide and long format. What are my options to match different datasets in Stata? The append command appends new observations over time, for example waves 1 to 13, or of different samples, for example anchor base and demotive data, creating a new dataset in long format. With the command one-to-one merge, two uniquely related actors can be merged into wide format, for example anchor with current partner. 1-to-m stands for one-to-many, and matches one reference actor with multiple corresponding actors. For example, one anchor with several parents. By using the reshape command, datasets can be reshaped from wide into long format or vice versa. How do I append demotive cases? On the left you can see three hypothetical rows of the anchor 1 and anchor 1 DD datasets, which each represent three respondents with a unique ID in wave 1. They have been asked the same questions, columns var1, var2 and var3. By using the append command, we can merge these two datasets into long format. The result is shown on the right. This format contains the same amount of variables and a combined number of rows from both datasets. The wave 1 demotive cases have been added to the pairfam base sample from wave 1. Please note that for the append command to run correctly, respondent IDs must be unique in both datasets, and variable names must be identical. What if I want to use the one-to-one merge command? For the merge command to run correctly, respondent IDs must be identical in both datasets, whereas variable names must differ. When merging anchor data with partner data from wave 1, the number of cases, rows, does not change. The combined dataset results in the same three rows or cases. However, the number of variables has increased. In addition to the variables ID, wave, var1, var2, and var3, the merged dataset also includes PID, pvar1, pvar2, and pvar3. When do I use the one-to-many merge command? As several parents and children of one anchor person may have also been interviewed, it is possible that several parents and children of one anchor respondent are available in the data. Looking at the anchor and parent data from wave 2 on the left side, we see that the anchor with the ID 100,000 is represented with 3 rows in the parent data, meaning 3 parents of this anchor have been interviewed. The variable par ID gives the identification number of the parent. In order to merge the data from all 3 parents to the anchor data, we need to run the one-to-many merge, merging one anchor to many parents. This process enlarges both the number of cases as well as the number of variables. Always check the resulting data carefully after matching different datasets, for example with the browse command, in order to make sure that the merging process was successful. Further and more detailed examples on how to match the pairfam datasets can be found in the Quick Start Matching. One last note on gender-specific analyses. If you have merged anchor and partner data into wide format, the dataset will contain 1 row per anchor-partner diet and several variables from both the anchor and partner respondents. For example, both the anchor's and the partner's satisfaction with the relationship. When conducting gender comparisons, please be aware that the anchor and partner can be male or female. One solution to this problem is gender-specific variable coding. For example, you could create a new variable representing women's satisfaction with the relationship by using the anchor's information if the anchor is female and the partner's information if the partner is female. And then create a new variable representing man's satisfaction with the relationship with the same logic. Please keep in mind that there are also homosexual relationships represented in the pairfam data. This marks the end of the 11th tutorial. The next tutorial covers a hands-on exercise on how to merge different pairfam datasets.